Hello guys and welcome. This is going to be the last video for Math League. Today we're going to do the last three questions, 34 to 37. And one interesting point is that these questions, each of them is worth 2 questions. So double the points. Usually questions have 10 points, but these questions have 20 points. And because this is the last video, I'm going to ask you for 2 things. Number 1, I've been teaching math and physics to the Chinese students for the past 3 years. What I'm interested in is that, are you all from China? So please, if you're watching this or if you're taking part in Math League, please let me know if you are in China and if you're Chinese. So that's, I'm really curious to know. So please leave it in the comments. The second thing is that, is there any other tests that you would like me to help you with, right? So that was like Math League contest. It could be physics, math. So if you have any ideas for other videos that I can make, like this one, please again, leave them in the comment section. Okay, so that's good. Let's start. Before we do question 37, 34 to 37, one interesting thing is that about this question, Bruce NG left a beautiful comment for this question, and it was this one that if you don't know the question, so let's just read it here. Let me make this smaller. Or if you have read it, just pause the video, read it again. Okay, I think his answer is brilliant. So let's see here. If we have the weights 1 and 3, so what different ways can we make with these two? Of course, we could make 1 kg. We just use this one. Okay, if we want 2 kgs, we would put 3 here, 1 here. That's like 2 kgs. If we want 3 kgs, we just use a 3 here. If we want 4 kgs, 4 kilograms, we use 3 plus 1. Okay. And what if we want 5 kgs? Okay, that's the next thing. See, if you want 5 kilograms, this is a total of 4 kg. If we want to create 5 kilograms, if we want to create 5 kilograms, what weight do we need to use? 9 kg. See, 9 kg minus 4 kg. So that means the next weight that is required is 9. So if we want 9 kg, if we want 5 kg, we'd put 9 here, 1 and 3 here. Okay, that's going to be 5 kilograms. You want 6 kilograms? Okay, these two. You want 7 kilograms, you put 9 here, 1 here, 3 here. Okay, you want 8 kilograms, 9 here. Okay, so you get the idea, right? So, and then what happens if we put all the 3 weights that we have, 1, 9, and 3, that's going to be 13 kgs, and we want 14. Okay, so what is the next one that we need? 27. Why? Because 27 minus all of these is 14. Okay, so you get the idea. You could check his comments. That was brilliant. That was really helpful, so I shared it with you. Okay, let's just start with the questions we're supposed to do today. Okay, they are really easy. Okay, so please pause the video and read the questions. Okay, so basically what it says, if we have 2 blue chameleons, if they are the same color, okay, they would be again the same color, but they change. If they're both blue, they become red. If they're both red, they become blue. And here, basically, you could also swap them. Huh. So let's see here. Please read question 1. We also are given a picture. We'll have 4 red. I'm gonna swap them with balls. 4 red. Okay, and then 4 blues. Okay, so basically we could swap them, right? And so let's see. First, if we select these 2, let's see what happens. They swap, right? So basically, these 2 will be close to one another. Okay, and let's swap 5 and 6. Ding, ding, ding. Huh. And then we could swap 7 and 8. And 6 and 7 are swapped. And this is very good. Okay, now you could easily see that, well, if you want all of them blue, these 2 and these 2, pink, and both of all of them are going to be blue. So if you want all of them to be red, these 2 and these 2. Okay, so the answer is yes, yes. It's possible for both of them. But why? See, so you have to do these questions step by step until you establish the general rule. So the thing is, can I put all of these in a way that makes it impossible, right? For example, can I put, if I put all the reds here and all the blues here, does it change anything? Right? So for example, if I have like this, or if I put them all in between, does it change anything? The answer is no, because we could swap any of them. So what makes it impossible is, for example, this one. This is interesting. See, if we do question 2, then you must be able to establish what goes on here. So we have 4 reds, 3 blues. Pay attention that one of them is even number, the other one is odd number. See, as I told you before, we could swap them any way we want. So let's put reds close to one another. So now you see 2 reds are close. And this is interesting. You could see now that, can all of them be blue? Yes. Why? Because these 2, the reds become bang, both blue, bang, both blue. So we have all the blues. But can we make all of them red? No, because one blue will be left either case. So basically, this question is very easy. If you want all of them be red, the blue ones have to be even number. If you want all of them to be red, the blues have to be even number. So it's very easy. So for the first question was yes, yes, because both of them were even. For this one, you can't make them all red because blues are 3. Good. Next one. Yeah, again, you see both of them are even. Yes, 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 yes. Question 3, yes, yes, yes. Question 4, no, 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 no. Why? Because, well, both of them are odd numbers. Question 5, okay, 7 and 12. After 7, is it possible to make? Okay, again, no. So this one, question 6, you know it better. This is even, this is an odd number. Can all of them be red? Yes. Why? Because blues, all the blues can be red. So can everything be blue? Well, we need all the reds to become blue, but this is an odd number, so impossible. So can all of them be blue? No. Okay, so that's it. Easy peasy, right? So question 36, again, the same thing. Read the question, pause it. Basically, you need to just remember the rules. If we have different colors, okay, they would create 2 of the same color. If both of them have the same color, they would start to create two colors except the blue. So basically, let's just see, for example, if I have one red and one yellow, what do they create? You must know this. They will create the color that is not here, that they create blue and blue. All right. If I have two red and red, what do they create? So for example, so we have yellow and yellow. The two yellows together, what do they create? They make one red, one blue. So that's the idea, right? Okay, so let's go and read the question. So please read question 1. Is it possible yeah, I'm gonna keep this here. So we have two blues, 5 reds, and we have 8 yellows. Okay, the first question. Is it possible that all of them become blue? To make all of them blue, okay. See, if these two match, okay. So both of these, bang, bang. So if we have 8 yellow, this becomes minus by 1. Reds were 5, it would be minus by 1. In exchange, blues will be plus by 2. Okay. So if we have this, so that means what? If we do it like this, you see, we have 5 reds and we have 8 yellows. If they are the same numbers, like red and yellow are the same, okay, then yes, all of them can be blue. Okay, but we could see right now that yellows are more. So what if these two, we select these two, what happens? Okay, these two yellow, one of them becomes red, the other one becomes blue, right? So this becomes 6. 1 will be added to it. Blue. This one is red. So what happens now? We have 6 reds and we have 6 yellows. Okay. So can all of them be blue? Yes. Why? Because these two, look, they have different colors and these two become blue and go here, blue, blue. These two together, blue, blue, blue. So the answer is, can all of them be blue? Yes. Okay. Now, the question is, can all of them be? Okay. Is it possible for every chameleon to become red? So again, we have 2 blues and we have 8 of these. Okay, remember, when we want to check if all of them can be red, the number of reds is not important. Only these two is important. So what happens here? We select 2 of these again. So this will be minus by 2. The blue will be plus by 1. This red also be plus by 1, but it's not really important. So this will be 3 blues. We will have 3 blues. And we'll have 6 yellows. And if we do it one more, again, yellows will be minus by 2. Okay, blues will be plus by 1, red will be plus by 1. Look what happened here. We'll have 4 blues and we will have 4 yellows. Okay, so eventually it would be 4, 4, right? So first we do 2 of them like this. 1 will be added to the blue, 1 will be added to red. I'm not going to do it. I'm not going to show it here. Again, we'll clean 2 from the yellows. And 1 will be added to the blue. So 4, 4. Now, how many reds do we have? It doesn't matter. All we know that is just now blues and yellows, they create 2 new reds. These two create 2 new reds. So is it possible for all of them to be red? Yes. Okay. Now, the last one of this question. Is it possible that all of them will be yellow? Okay, I'm going to show it like this time. We'll have 5 reds, 2 blues, and 8 yellows. Is the number of yellow important in this question? If all of them are going to be yellow? No. The only thing is blue and red. This would be minus by 2. This would be plus by 1. So as you could see, the number of blues will become 3. Red will become 3. And now each blue and each red, bang, they create 2 new yellows. Is it possible for all of them to be yellow? Yes. So again, for this question, yes, yes, yes. But did you manage to establish the rule? Okay, why is it like that? So is it possible for all of them to be blue? Right, we have 15 blues. Okay, 43 reds. 34. Is it possible that all of them be blue? Well, the number blue is not important. Here is going to be 43 minus 34. Okay, it's going to be 9, right? That's the key. Okay, if I subtract these two numbers, the answer will be 9. Okay, if 9 is a multiple of 3, the answer is yes, all of them can be blue. That's the rule. Why? Because each time, remember, each time that we, the big number, we minus the big number by 2, okay, yellow one will be added by 1. Okay, so 2 go down, 1 go up. 2 go down, 1 go up. So if it's a multiple of 3, the answer will be yes. Okay, so can all of them be blue? Yes. So let's go. Can all of them be red? Red is not important. What is 34 minus 15? 19, isn't it? Yes. So 19 is 19 multiple of 4? No. So can all of them be red? No. So how about yellow? Can everything be yellow? So in this case, I subtract these two. So is it 28? I think, yes. So 28, is 28 a multiple of 3? No. Can all of them be yellow? No. See how easy it is? Yes. Okay, so basically, that's the general rule. I'm not going to do it. You're going to do it yourself. These questions. So basically for this one, if you want to know if it's blue, you subtract these two numbers, the big number minus the smaller number. If this number you can divide it by 3, can be divided by 3, is divisible by 3, the answer would be yes, all of them can be blue. Okay. So here, question 4 and 5. Okay. Please write the answer. The general rule is this. So here, is the above situation possible for this one? Yes or no? For question 5, yes or no? Not gonna do them, but it's easy. When you say, for example, if you say, is the above situation yes? We could also write the example in the comments, like with which one, okay? So for example, you could say 1 blue, 1 red, 1 yellow will be the answer. So yes, it is possible. You write it, you leave it in the comment section below. Okay. So the last one is pretty much like the previous question. Nothing new about it. If they are the same color, you would create new colors. All different colors will create. So you get the idea, right? So again, is it possible? But the rule is like the previous question. If you understood the previous question well, then no challenge with this one. We'll have 2 blues. So let's see it here. 2 blues, 6 reds. Ooh. 3, 4, 5, 6 reds. 8 yellows. 1, 2, 3, 4, 5, 6, 7, 8. And purples. I have purple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So after some time passes, is it possible for every chameleon to become blue? Okay. So if you want everything to be blue, the number of blue is not important. Okay. So in this case, well, if all of them were the same, then the answer would be an easy yes, because 1 red, 1 yellow, and 1 purple from here together, they will create 3 blues. Okay. Then the answer would be an easy yes. But now some of them are larger than the other one. So what is the largest one? The largest one is purple. Okay. So purple will be minus by 3. We'll choose 3 like this picture, exactly like this picture. So this will be minus by 3, but each one will be added by 1. This will be added by 1, added by 1, added by 1. Okay, so we'll have 7 of these, 9 of these, 7 of these. Okay, this will be 3 of these. Okay, so as you see, this one is now 9 is bigger, so 9 will be minus by, let's see, 3. Each one will be plus by 1, plus by 1, again plus by 1. So what do we end up with? We will end up, I'm going to change my color, with 5 blues, not very important, with, let's see, with, I think it's 8, will be 8, and then will be 8 here, and then will be 6 here. Okay. So again, we have to minus these ones. Let's just see it here. So we're ending up with these. We'll have 6 yellows. Okay. 8 purples. Okay, the number of blues is not really important. So again, this will be minus by 3. This one plus by 1. This one plus by 1. I'm not going to do it on the blues. So we're going to be ending up with 9, 7, and 5. Okay. And then let's see, let's do it on the 9. 9 again, minus by 3. This plus by 1. This plus by 1. Okay. So this will be 6, 8, and 6. Okay. Okay, this is the idea. So 6, we'll have 6 reds, 8 yellows, and again 6 purples. Okay. So again, the last time we choose 3 yellows. Yellows will be minus by 3. This will be plus by 1. This will be plus by 1. So again, not quite there. You see, this will be 7, 5, and 7. So we kind of get the idea, right? So is it possible, well, for all of them to be yellow, to all of them to be blue? The answer would be no. Okay. But why is that a no? Because the answer will lie in these 3. Okay. So for example, the previous question, we subtracted the number, they had to be divisible by 3. But this time they have to be divisible by another number. Okay. So the answer for this one is a no. But the answer for can all of them be yellow? The answer would be yes. Okay. If we want all of them to be yellow, it would be possible. Okay, let's see why yellow is possible. Because we'll have 8 yellows. Okay, 2 blues, 6 red, and 10 purple. So we want everything to be yellow. So we don't care about yellow. This number is not important. But let's pay attention. 6 minus 2 is 4. 10 minus 6 is 4. That's key. Why? Because this is going to be minus by 3, plus by 1, plus by 1. So 7 is going to end up with 7, 7, 3. Okay. So, and then let's see, with 7, one of the 7s is going to be minus by 3. Okay, this one will be plus by 1. This one will be plus by 1. Okay. So this would be a 4, 8, and a 4. Okay, you could still see that the big number minus the small numbers will create 4s. 8 minus 4, 8 minus 4. And then again, this one, minus by 3, plus by 1, plus by 1. So this will be 5, 5, and 5. So we'll end up with 5 purples, 5 reds, and 5 blues. That's exactly what we need, because they could think. Okay, they could, each of these 3 will create 3 new yellows. So the answer to yellow is yes. So let's see the other question. If we want to see if all of them can be blue, we need to minus these. 36 minus 40, 5 minus 36 will create a 9. Is 9 divisible by 4? No. Can all of them be blue? No. So is it possible for all of them be red? Okay, so yeah, this would not be important. Yellow minus blue will be 10. No. Okay. Is it possible for all of them to be yellow? 48 minus 45 is 3. No, it has to be 4 or a multiple of 4. Okay, is it possible all of them become purple? Well, we have to minus them all. So this is going to be 19 if we subtract them. So the answer will be no, 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 no for question 2. Okay, so you get the idea here. So if you want to see all of them are blue, I'm not going to do it. The numbers are large. So you would subtract these 2 numbers, all the 3 numbers. This one by this one, and this one by this one. If all of them are a multiple of 4, the answer would be yes. If they're not, no. Okay, so I think we are good with these questions. So basically, again, for these questions, you could also share your answers. Okay, for question would be question 37. Okay, part 4 and 5. Again, if you say yes, if you say no, come up with write your possible answers in the comment sections below. Okay, that brings the whole thing to an end. So I hope the videos were useful for you. So, and again, give me ideas for the future videos. That's enough for today. Take care and bye-bye.